Good morning, everyone. Happy Friday.
Happy Friday.
Yeah.
Morning.
Okay. So, yeah, I think today we are going to continue our, lecture for the reliable transfer protocol, right? So before that, I would like to first, next week, next Monday, I need to have um, conference presentation. The time is exactly conflict with our class, and I'm thinking about to upload the video of that. So I will send an announcement, so you can watch the video of that. So this is the first thing. Second is today is the second assignment due, right? Don't forget about that. And I think I suggest that you starting the third one as soon as possible, because some of you may not be very familiar with the Python, may not be very familiar with the socket programming. So I suggest you starting as soon as possible. So maybe next Monday, right? So if you have time, you just use the class time to do the homework assignment 3. Okay. For the midterm, I received a email from some students asking what kind of what type of or something. So I think the exam would be based on the something like assignment 1, assignment 2, right? The question and answer. Will not have any programming or something, but the final exam, because it's taken home, it could be slightly different, but I will announce later. But for the midterm, it will be exactly the assignments, okay? Similar to assignments, okay? Not exactly the same question, okay? But similar, pretty similar. It just ask you to yes or no, or calculate something, okay? Or just answer some concepts or something, okay? Uh,
Is the midterm take home?
yes.
Okay. Thank you
Uh,
for the clarification.
yes, yes. For the final one, I'm still thinking about if the still assignment, because for the later part of the, you can see that for the later part of our course, right? So more and more concepts about the protocol or programming. So um, it could be mixed, right? Half of the question is just also the question and answer, but maybe several ones just ask you to submit some code. But I will let you know later. Okay, let's first focus on the midterm. So I will send an announcement later today, because I see not all the students here. Okay, but if someone asks you what type of the midterm, you can clarify to them. Okay, similar to our assignments 1 and 2. So here are some clarifications. Okay. Okay. So if it sounds good to you, let's go to our lecture. Okay. If you have any question, just feel free to ask in the chat. Okay. Let me share my screen. I want to do a quick review of what we have discussed the last lecture, because as I emphasized, the FSM, finite state machine, may not be so easy for you, right? So kind of the new concept to most of you. So we need to know how we can use this specification to demonstrate different protocols, okay? So we have the different reliable transfer protocol. Here I want to do a clarification as well. So the reliable data transfer protocol is not exactly the thing in what we're going to talk about TCP, right? So it's a reliable data transfer protocol. It has different version. The concept would be used for the TCP development, but it's not exactly the same, right? Here's a clarification. So we will talk about what's because there are several, you can see here is RDT 1.0, 2.0, 3.0, right? So for the 3.0, we have different branches or different variances, but not exactly the same as the TCP. So we will see what is the difference, what is the same, right? But we need to go through the principles for the reliable data transfer protocol, right? For the first one is the simplest one, is the most straightforward one, right? No error, no anything bad happening, right? So if you still remember the FSM, right? So we are using this specification to denote which condition will, or which how states will change between each other, right? Which triggers the state to change. So that's the key, right? So if we don't have any error here, the sender just what trigger it, right? So just sends the data, right? And the receiver is just receive the data, right? It's no fancy thing here, but this is not the case we want to focus because this is too perfect, right? Too easy. So the second is a channel with a bit errors. Some bad thing happen, right? Some bit flip happens. Still remember we were talking about the checksum, right? So channel may bit flips in packet, may bit flips in packet. So how should we recover from the error, right? We can detect, but how we can recover? And um, we talk about the acknowledgement and negative acknowledgement, right? Still remember, this is not difficult, but for this figure or for this diagrams, we want to show that for sender, right? So it has two states. One is the wait call from above application, right? And another is a wait for acknowledgement or negative acknowledgement, right? And which condition trigger the state change. So wait from call from above would be changed to the wait for acknowledgement or negative acknowledgement. So the condition would be you sending the data, right? You make a packet and you send the data through the unreliable data transfer protocol, right? The channel, okay? And we trigger the state back, right? It's just you receive the acknowledgement and you have received the packet, right? So which will make the state looping, right? Just you don't receive the acknowledgement, or you receive the negative acknowledgement and receive the packet, right? And then you just resend the packet. So this is the sender. Receiver is a simple here. It's just a wait from the call from above you receive, and if the data is corrupted, and you just send the negative acknowledgement. And if you receive the data no corrupted based on the checksum, right, and you just send the acknowledgement, okay, and deliver the data to the above application, right? So it's always in this state, right? So then our question, we ended up here to last lecture, right? And then our question is that receiver and the sender, they don't know each other's states, right? We have to have some communication, right, in the protocol to make the information switched or exchanged, right? So they don't know each other. The other part just blind to themselves. So we need to have some communication here, okay? And what kind of the communication could be linked here. So first, if we have the sender, right? So let's just go through different processes. So the first is a sender wait a call from above application and then send the data, right? This is the receiver. And the first, if the everything is good, right? Just send the data and the sender change the states to the wait for acknowledgement or negative acknowledgement. And the receiver receives the data and nothing bad here. Okay, no data corruption, no bit flip, right? So no corrupt. And it then will reply, right? Extract the data, deliver the data, then send the acknowledgement back, right? And after the sender receives the acknowledgement, it just receives the packet, and sender knows that, okay, the packet has been delivered, right? No bad thing happened. Okay, so this is the first situation. What about the second situation? The second situation is that you send the packet, but the packet has been broken, right? The corrupted. So the receiver just send the NAK, right, back to the a receiver sends the NAK back to the sender, right? Then the sender receives the packet and the negative acknowledgement, right? And then it's just a loop here, right? The state will not be changed because receiver doesn't receive the correct packet, right? You just loop here, the state will not change, and the UDT send the packet again, right? Just send the packet again, and then it goes through to the correct path, right? The receive the packet and the no corrupt here, and it replies to the sender, okay? No corruption, acknowledgement, and the receiver receives the data, right? The packet. So that's it, right? So that's it. That's two different situations in this protocol, right? We only consider these two situations in this protocol. Okay. So why we want to use FSM to demonstrate here or just illustrate here, right? So you can simply see different path go through the different states between the sender and the receivers, right? And yeah, it's easy for people to understand how the protocol would be developed here. Okay, so this is RDT 2.0, right? 2.0. No question, no question. Then we'll go to the 2.1, 2.2, and then 3.0, right? But we will speed up. But my point is that the other things are similar, but consider the extra situation, something are not included in this case, but generally speaking, we develop more and more complicated protocols to cover more and more situations, right? This is how people developing a thing, right? A scientific thing, right? So you just start with a simple situation, you add more and more situations you need to cover, and you develop more and more complicated protocols, right? But the base is a simple protocol to start with, right? This is how you, in the future, no matter you do a research job or the development job, engineering job, is starting from simple to complicated, right? So this is similar. Okay, so this is RDT 2.0. Okay, let's go to the, there is something the RDT 2.0 doesn't cover, right? So this is what I mean. Things become more complicated, and there is some situation you don't cover in this case, then we develop more or better protocols here, right? So what is drawback, right, of the RDT 2.0. So what happens if the acknowledgement or non-negative acknowledgement or NAK, ACK, right, is corrupted? What about this case, right? So you, just as I mentioned, as I mentioned in the checksum, right? You want checksum to be always correct, right? This is the assumption, but sometimes it's not. And similar here, the ACK and the NAK is not always be correct, right? It could be corrupted, right? It could be lost, right? Because every time you send a packet, you need to reply acknowledgement. The frequency is similar, right? Or I mean, all one-to-one, right? Every packet with every acknowledgement. So that means packet be lost, then the acknowledgement or NAK could be lost too, right? So what happened if the ACK and the NAK corrupted, right? Sender doesn't know what happened in other receiver, right? And they cannot just retransmit possible duplicate, right? If you, for example, I'm waiting here, I'm waiting for the acknowledgement or negative acknowledgement, but I don't receive anything, right? Means that I don't know what happened to receiver, right? No response, right? No response is the worst case, right? You respond no or yes, I know what happened, but if you don't respond, right, then I don't know what happened, right? So this is the worst case, how we can conquer this case, right, this situation. So if I just retransmit, right, resend, that may not be good because it could be duplicate, right? And the receiver even doesn't know if the packet it receives is a duplicate or not. So I think the simple solution is just we give each packet a sequence number, right? You can resend, but if I receive something duplicated, I'm fine. I just discard the duplicate thing, right? But in this RDT 2.0, we don't have sequence number, right? We didn't mention sequence number, okay? We only recognize or use individual packet, right, to send and receive. So the solution is that how we can handling the duplicates. So we just send, transmit, retransmit the current packet if ACK or NAK is corrupted, and we add a sequence number to each packet. That's a simple solution, right? If you don't know if you receive anything duplicated, you just use a number, right? So that's why every important file has a number, right? You just use the file number to see if it's a duplicate or not, right? It's like um, every file also have some sum or checksum or something to see if it's a duplicate or not, right? Here's the same design. So if we have the sequence number, um, what the protocol would be changed, right? That's our problem. That's our question, right? And the sender sends one packet, then waits for receiver response. That's the same not assumption, but the same requirement, right? You just stop and wait, right? If you don't receive anything, you just stop there, right? Then our protocol will be slightly adjusted because now we have different sequences, right? And then the states need to be adapted to different sequences, right? So the states would be based on the sequence number as well, because sequence number is also a triggering condition to change the states, right? So that's why here we double the states from 2 to 4 if we considering 2 packets here, right? Packet 1, packet 2, okay? So let's say we have 4 states here. So first is a wait call 0 from above. You send the packet 1, right? Wait the call 0 for packet 1. Okay, and then you wait the acknowledgement or negative acknowledgement for packet 0, right? Call 0, right? So which triggers a state to be changed? So it's you send the data, right? And how you send the data, as we described last lecture, right? Is to just make a packet. The packet needs to have a sequence number, right? So let me use a laser pointer. So here is the number, right? The sequence number. Because previously when you made the packet, you don't need to care about the sequence number in the RDT 2.0, right? Because we don't distinguish different sequences. We don't distinguish different packets, right? So that means we cannot take care of the if you cannot receive acknowledgement on negative acknowledgement. But now if we add a sequence number, here when we make a packet, you need to give a number here, right? Because this is a call 0, we make a packet 0, right? Okay. Similarly, I think it's just similarly because I will talk about what is different, but similarly, sequence 0, sequence 1 is just previously you have the two sequences in RDT 2.0, right? It's similar. And after you have acknowledgement states, how you change or trigger, what's the condition trigger you to change from this state to that state, right? These two states, you just receive the packet. If it's not corrupted and is acknowledgement, right? Three conditions here, and then it change to the next call from above because this packet has been received, no corrupted, then I can continue to the next packet here, right? So wait for call 1 from above. Similarly, you just a symmetric, right? This is just a symmetric, right? You just send the data, but the data with the makeup packet with a different number from 0 to 1. This is just symmetric. As I mentioned, I just double the states, right? Because I have the sequence, different two sequence numbers here. I just double, okay? Nothing fancy so far, right? Similar to the RDT 2.1. Okay, this is similar, right? Receive the data, receive the packet, and no corrupted, the exact acknowledgement, right? And everything is the same. Okay. Then what is the difference, right? That's a question, right? What's the difference? So let's see first here. If you receive the packet and if you packet the corrupted or the non-negative acknowledgement, then it's looping. This is the same, right? In RDT 2.1, we also have this looping, right? Remember? Remember? If you don't remember, let's go back to see the slides again. Right? Here is the same, right? And the looping here is the same, right? But we double, right? So in the center side, so this is the same, right? Let me just quickly change the slides. Sorry. Okay, these are the same. And this is the same as well, right? And the symmetrically here should be another one, right? It just receives some corrupted acknowledgement, right? So what's the difference? I think the difference is not in the sender part, because as we mentioned, the duplicate thing would be happening in receiver part, right? For sender, it's just you wait for some time, you don't receive the acknowledgement, right? And then you just resend, right? So for this status, I think it's the same, right? But from the receiver side, it could be different, right? So because now we have the two states for receiver. Previously we only have one, right? But now which condition trigger the state change, right? From 1 to 0 is just you receive no corrupted has a sequence, right? From 1 to 0 is the same. You receive the packet and no corrupted, and you receive the sequence 1, right? But if there is some duplicate, for example, if you wait 1 from above or from below this state, you want to change to 0, but you receive the packet is not the one you want, means it's duplicate. At that time, it's just a looping here. Okay, so here you can see this is a difference. I think this is the same, right? Previously, we also have the corrupted case, it's just a looping here. Okay, I think the only difference if you have the sequence number or not is here, because this one will also make this state looping, okay? Because you receive something you don't want to receive, right? You should receive the packet, here I think receive the packet if you want to change to state 1, that means you need to receive the packet 0 with the sequence number. Sorry, you should receive the sequence 1 with the sequence number 1, right? But if you receive the 0, that means you loop here. Similarly for this one as well, right? You receive something duplicated or something you don't expect to receive. Then it's just a looping here. Okay, so if you think that, let me just try to repeat or emphasize that again. If you think about the difference between RDT 2.1 and 2.0, the difference that we give the sequence, we give the packet a sequence number, or sequence number, right? Because we want to know if the packet you receive is duplicated or not, right? From the sender part, it's the same, because if the acknowledgement or non-acknowledgement is bad or is broken, is corrupted, right? Just a resend. But from the receiver side, you need to have another condition to trigger this loop. Previously, we only have one, right? You still remember, we only have a one state, and only the thing to trigger here is a receive or not receive, right? But here, we have another condition that we receive the packet is not supposed to be received. Okay, so here you can see that we have another condition is not corrupted, right? You receive the packet is good, but the number is not good. The sequence number is not good. So we're still waiting here. We're waiting for the non-duplicate packet, right? So that's another condition to trigger the looping here. Okay, so maybe a little bit confused at the beginning. You see this figure. I'll try my best to explain here. So any question before I go to the next one? So I think that the quick summary is just we double the states because we have the two sequences here, right? And everything else is the same. It's just a double, right? From one state to another state. The difference is that if you receive some duplicate, you still wait here, right? And you want to receive a packet is not duplicated. Okay, so I can show animation later. So maybe I think I should show first to avoid if you have some confusion here before I go to the. That is something here, right? So if you see this one, you send a packet, but the acknowledgement is not received, is lost here or broken here. Then it just resend the packet and send the acknowledgement back. But you can see here, this is a duplicated packet, right? So the protocol is want to handle this part because it detect duplicate. You don't expect to receive the packet 1 because packet 1 has been already received. You are expecting the packet 0 to change the state, right? But you receive a duplicate. So you just loop here to until you receiving the another packet 0 here. So I just want to show some animation in advance because some of you may be confused here. But this animation may help you to understand. Let's see this animation again. You send a packet, receive the packet acknowledgement and send the packet 0, but the acknowledgement is not good, right? And then, so we are talking about timeout here, but you just assume that the acknowledgement 1 is not received very well, right? And then the sender just resend the packet 1, and the receiver notice that the packet 1 is a duplicate, right? So it's just looping here until the receiver receives the correct acknowledgement 1 and packet 1, right? So that's the question RDT 2.0 want to solve. Okay, it's just how to deal with duplicates here. Okay, am I clear here? Any question before I go to next? a lot of words here, but you may not want to go into every word very detailed at the beginning because you need to focus on the big picture, right? The big picture is received and um, cropped or not cropped, right? But this is not cropped, but it receives the wrong sequence, right? And the contents below this line is just how it will be implemented, right? If you don't want to see that first, it's okay. You just focus on which condition triggers the state change. And if you want to know a detail about how this would be implemented of that, then you just see these functions here, APIs here, right? So here is a quick suggestion for you how to look at this figure. Otherwise, you may think this is a too complicated um, diagram, right? Okay, so if it makes sense to you, let's go to the next one, the ANK free protocol. So I think this is just a quick upgrade. It's not too much fancy, right? So the point is just we don't want to use the NAK. We just want to see because if you have the NAK or ACK, right? Actually, they are the opposite, right? Counterpart, right? So you don't need to do the negative acknowledgement. The solution is that you receiver explicitly include sequence number of the packet being acknowledgement. Means that which packet you have been received. You just keep noticing the sender, right? You don't need to tell him or tell the sender that I don't receive what. You just keep saying that I receive what, I receive what, I receive what. If the sender notice that what you acknowledged is not the updated one, then it means NAK. Right? Does it make sense? If we choose send a message, right? You want to know, okay, if you receive the packet 3, I keep telling you that I receive packet 2, I receive packet 2, I receive packet 2, means that I don't receive packet 3, right? So this is just a very, I mean, simple strategy, right? You don't tell him I receive packet 3 or not receive packet 3. I just tell him I receive packet 2, I receive packet 2, I receive packet 2. Means that the updated or latest packet I receive is packet 2, right? Meaning I don't receive packet 3. So using this such a small point, we can just remove the negative acknowledgement because we have sequence number, right? Previously, we don't have sequence number. We have to use acknowledgement or negative acknowledgement, right? But now we have sequence number. We just use the sequence number to identify or to let the sender know if I receive the updated one, right? So that's just the point here. So here we don't use negative acknowledgement NAK. We just use is acknowledgement receive one, means that I receive one, right? I receive packet one. Okay, the updated one I got is packet 1, right? So here is I receive packet 1, but you should supposed to receive the packet 0 to change the states, right? If this is not the case, just looping here, okay? If I receive the packet 0, then means I'm good. I should change from the wait for acknowledge 0 to the next wait for the call 1, right? So that's a small point. One improved version of the 2.1. Okay. I think sometimes this is just a theoretical protocols idea, but it's also be usable, or maybe you can think in people communication as well, right? You don't want to um, criticize some people, right? You just saying something, okay, I think that would be good, that would be good, right? But you don't say that this is not good. Similar here, right? I don't say that I don't receive this package. I just saying that I only receive the packet 1, I only receive packet 1. The same thing, right? So this is a small point or small or I mean strategy to remove the NAK, sorry, NAK, negative acknowledgement, right? So we will make the RDT as a NAK-free protocol, right? I only send the acknowledgement. I don't send the negative acknowledgement, okay? Similar here, okay, for the receiver side, right? I just acknowledgement which packet I have been received, okay? Is that clear? I think this is a 2.2 is not much different between the 2.1. If you understand 2.1, these 4 states, right? This is most important 4 states and these 2 states, right? And then I think you should be good, okay? You should be good. 2.2 is just improved to save the NAK, okay? Then let's go to the final RDT protocol 3.0, right? What's the difference between 3.0 and 2.0? What kind of the situation we want to solve here? It makes the protocol more reliable, robust, okay? I think we almost cover all the cases. But the only case maybe we don't cover so far is that if sometimes the network is not very, the bandwidth is not very stable, right? The packet is not totally lost. It's just in very slow transmission speed, okay? Sometimes you receive the packet in delay. Sometimes you receive the acknowledgement in delay, right? How you should deal with this case. I cannot wait there forever, right? We talk about stop and wait, but we don't really mean we want to wait forever, right? If the network is very unstable, sometimes if you wait for example, 100 microsecond, right? You don't want to wait anymore. You just need to pass that, right? To treat it as a lost or something. But after that, if you receive the packet again, right, it will eventually arrive. How you should deal with such a situation? Something here, right? You can think about previously, our assumption is like ideal, perfect lost, received, right? We don't have some intermediate states. It's slowly delivered, right? Something like this, and eventually get, but during some time period, it doesn't get, right? So this situation we should be considered for the this protocol, right? How human handle lost sender to receiver was in conversation, right? This is as I mentioned, you can always compare to how people are doing this. So retransmit if no acknowledgement received this time. But if the packet or acknowledgement just a delay, as I mentioned, not totally lost, the retransmission will be duplicated. But sequence number already handle this. Receiver must specify sequence number of packet being acknowledged. Okay, how we can handle if it's a delay? We just use a countdown timer, right? It's a I mean, it's a common thing in the computer system programming engineering, right? You have to have a timer. If it's a timeout, you just give up, right? Or do something else to handle this timeout, right? Yeah, I mean, it's not good waiting there forever, right? It's just like an infinite loop. It's not good, right? So you have to set up some timer. But I think the main framework here is based on the 2.1 or 2.2, right? Or it should be 2.2 because 2.2 has a no NAK, right? So just say the 2.2 or 2.1. They are both 2 point something, right? Because they are similar. But the 3.0 is kind of different because we introduced timer here, okay? So see the same thing, right? We have the two sequences, right? We have the two calls, we have the two packets here, right? Whatever you want to say, but just two copies, two something here, right? And then similarly, we have the four states. What we have added here, we just add a timer, right? We start a timer because we want to know if the data you send and within certain time, you have received that or not, right? You have to start a timer here. Okay, then anything else is the same, it's just the same, right? And receive the packet, you receive the, receive the acknowledgement, right? The packet with the acknowledgement, then the timer stop, right? You just have a one back and forth, right? One round. So you stop the timer. Similarly, here you start timer, you end a timer, right? For the sender part, right? And which will trigger you looping here. Previously, we have a condition is the the NAK, right? Or the data is broken, or we replace the NAK by the sequence number you are not supposed to receive, right? That's some similar thing I just explained, right? Here we add a new condition. Because we have a timer, you have to use timer, right? Otherwise, it doesn't make sense to add a timer. So we have something here is a timeout, right? You just timeout. You wait for acknowledgement, but you don't receive the acknowledgement. It's timeout, so you resend, right? You're waiting for some people to reply your email, but he or she doesn't reply your email. How you should do? You set a timer for yourself, right? Everyone may have a different patience. One have a timer for 1 day, one have timer for 1 week, right? If I'm a person like I don't have much patience, I just have set a timer for 1 day. Someone doesn't reply my email, I may kindly resend or request them to acknowledge my email, for example, right? So here is the same thing, right? You wait for acknowledgement, but you don't receive that, the state will not change. You just use a timer to do a resend, right? Other things are the same, right? You receive the corrupted, is acknowledged, or I mean here we merge the previous two conditions, right? Is corrupted, or you receive some packet is not supposed, or you are not expecting that, right? So we merge the two conditions in one sentence here, and we add a new one here. So if you want to write one condition here, let's say, you receive a packet and the packet is corrupted or is not the packet you're supposed to receive, or timeout, right? Or timeout. I mean, the timeout should be or between this and you just add another or here, right? You don't receive anything, receive nothing, right? And the or timeout. Similarly, symmetrically here, right? You just add timeout here, okay? So here is protocol RDT 3.0. Mostly we add timeout here, okay? You want to make sure that the packet has been delivered in time, right? The time is this a new metric here, right? Previously, we don't consider time. We just consider yes or no, receive or not, corrupted or not. But here we introduce a new dimension, the time, right? So the protocol would be added with a timer and the timeout here, marked in yellow for timer, pink for timeout, right? What about the, this is the same, right? What about the receiver part? I think the receiver part is the same, right? Because the timer always been put in the sender side, okay? Any question here? Okay, so then let's go to the animation. I think most of your students, at least when I was a student, I like to watch animation or the video, right? It's easy for you to understand. So I just show one, but let's finish other ones. So here is the nothing, lost, send, receive, right? It's just a simple, right? Okay, before going to the next. Yeah. Okay, so this is the first one, right? The next one is the packet loss. We mentioned that a packet loss, you just receive the packet 0 and acknowledgement 0, right? And I send the packet as 1, loss, then timeout, I resend because the receiver expecting the packet 1 and send the acknowledgement 1 back, right? It's good, right? It's just resend, retransmit. Okay, so for this one, I just showed the difference that you receive the packet, but you don't receive the acknowledgement. The acknowledgement makes the timeout, right? You just retransmit packet, but the packet is duplicated. As we mentioned, we have a sequence number to identify if it's a duplicate or not. If it's duplicate, just a looping here for the receiver, right? The receiver is still waiting for the packet 0. So the sender resends the packet 1 and then go to packet 0. After the packet 0 received, the receiver just change the states, right? So this is a ACK loss. So the last one may be the most complicated thing, but I don't think it's much difference. It's just like a delay. Okay, you send the acknowledgement, it's delay, right? It's not lost, it's just a delay. But the timer also let the sender know that, okay, it's timeout, you should send the resend, you should resend, right? The timer just pushes the sender to resend. Okay, it's a resend. Packet 1, it's detected duplicate. So right is just duplicated and the state doesn't change for the receiver side, and it just send the acknowledge 1 back, and that the receiver the sender eventually receives this delayed package here, right? I should use a laser, sorry. Okay, here, okay. So eventually the acknowledgement 1 received here, okay? Before the second packet, I mean, you can see here, the packet 1 send and acknowledgement received, but this is delay. Before the received, the sender just resend the packet 1 and the acknowledgement sending back. But you can see here is some time gap, right? Like people are not in synchronized states, right? You ask something, for example, I reply email to recheck something. But during the meantime, the people just read my email and reply. So we have some unsynchronized things here, right? So you can see here the acknowledgement is just been received, and you send the acknowledgement 1 again because you don't know that, right? And this is a duplicated acknowledgement for the sender side, right? You just acknowledge that. Sorry, you just ignore that, right? You just continue to the next packet. So this not much difference, but just you have the acknowledgement 1 is not totally lost, right? It's just a delay, eventually received, but the packet 1 has been resended, okay? And the acknowledgement has been resended, and it's just a duplicated acknowledgement 1. You just ignore that, it's okay, right? Let me quickly see if there's a question. Can the sender tell the difference between B and C? I don't think so. I think for the sender part, it just just know that the time is out, right? We send the packet 1. It doesn't know if the packet 1 is lost or the acknowledgement 1 is lost, right? But the receiver part does definitely know that because it detected the duplicate. So that's a good question. So I don't think a sender know that, okay? But it doesn't matter, just a resend, right? No or not no is okay. For the D part, it knows because you receive 2 times of acknowledgement, right? because it's a delay to receiver. So this is a different. Okay. So any question? I think I use up all the time today. Any question? So maybe some of you are not here. Next week, Monday, I will not be here. I will upload a video later. Okay, so you can check out the video after class. Okay, if there is no question, let's end up today. Okay, thank you everyone. So if you have any question, you can send me an email or just let the TA know that. Okay, thank you. Have a good weekend. See you next Wednesday. Okay, bye-bye.